Children, let's discuss the second session. Children, let's move on to the second session. So, in this session, we will discuss different forms of energy. Apart from kinetic and potential energy, there are various forms of energy in nature. So, the first one is heat. The work done by friction is not lost, but is transferred as heat energy. And you also know, whenever current flows through a conductor, some amount of energy, electrical energy, is lost in the form of heat. Okay, so that is heat. It is a form of energy and it always flows from a lower temperature to higher temperature region. And we will discuss more about heat and temperature in our thermodynamics chapter. Then next form of energy is chemical energy. Chemical energy arises from the fact that the molecules participating in the chemical reaction have different binding energies. If the total energy of the reactants is more than the products of the reaction, heat is released and the reaction is said to be an exothermic reaction. You had already studied about exothermic and endothermic reaction in your chemistry classes. Here there is an example for exothermic reaction. When you freeze water, you remove energy from water to lower its temperature and its phase is changed to ice. So it is an exothermic process. If the reverse is true, heat is absorbed and the reaction is endothermic. That means endothermic is the just reverse process of exothermic reaction. While melting the ice, you provide energy to the ice to increase its temperature and change its phase to water. So it is an endothermic process. Okay, so chemical energy arises due to the different binding energies of the molecules participating in the chemical reaction. Next form of energy is electrical energy. The flow of electrical current causes bulbs to glow, fans to rotate, and bells to ring. Energy associated with the electric current is electrical energy. Another form of energy is nuclear energy. The energy released from the nuclear reactions, either fission or fusion, is called nuclear energy. And you had studied about fission and fusion in your class 10 physics. Sources of energy. Nuclear fusion and fission are manifestations or examples of equivalence of mass and energy. The famous mass energy equivalence, E equal to mc square. In fusion, what happens? Light atom or nuclei like hydrogen fuse to form a bigger nucleus, and the mass of this bigger nucleus is less than the sum of masses of the reactants. Okay, and what happens in fission? In fission, a heavy nucleus like uranium is split by a neutron into lighter nuclei. Once again, the final mass is less than the initial mass, and this mass difference translates into energy. Okay, so in both fusion and fission, there is always a difference between the masses of reactants and products. So this difference in mass is converted to energy, and this energy appears as this nuclear energy. In fusion, lighter nuclei fuse or combine to form a bigger nucleus, whereas in fission, a heavy nucleus splits into two or more lighter nuclei. Okay. Now, what is the principle of conservation of energy? If the forces involved are non-conservative, part of the mechanical energy may get transformed into other forms such as heat, light, and sound. Okay. However, the total energy of an isolated system does not change. Since the universe as a whole may be viewed as an isolated system, the total energy of the universe is constant. So what is the principle of conservation of energy? Energy can neither be created nor be destroyed. It can only be transformed from one form to another form. That means the total energy of the universe is constant, or total energy of any isolated system is a constant. We can consider universe as an isolated system. Okay. And what is power? You had already studied about power in your class 9 physics. Power is defined as the time rate at which work is done or energy is transferred. Okay, that means the rate of change of work, that is power. Power P is equal to work divided by time. So power is both how much work you do and how fast you do it. What is average power? Average power is the ratio of work done in a total time interval of T. That means average power is equal to work divided by time. What is instantaneous power? When the time interval T approaches 0, the limiting value of average power becomes instantaneous power. Just like our instantaneous velocity, instantaneous acceleration, power P is equal to dW by dt, where dW is the change in work and dt is the time gap or the time interval. We can write work done W equal to force into displacement, that is F dot dr. Here dr represents the displacement. Then power P is equal to F dot dr divided by dt, work divided by time. So power P is equal to F dot V, where V is the instantaneous velocity. Here dr by dt is equivalent to velocity V. Dr by dt, displacement by time. Dr means displacement, dt is time. So displacement by time is our velocity. And to be more specific, this is the expression for instantaneous velocity. So power P is equal to force into velocity. Remember this expression, power P is equal to force into velocity. This is a new expression for you. Then power is a scalar quantity, so it doesn't imply any direction. It has only magnitude. SI unit of power is watt, and horsepower is also there. Power can also be expressed in another unit called horsepower, and 1 horsepower is equal to 746 watt. 1 horsepower is equal to 746 watt. So that's all about power. So with this I am concluding my session. Notes of the topic and YouTube video have been uploaded. Just go through it. Attend the test and post me the answers quickly. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.